We are three students from PS University, Bangalore, Karnataka. Our research paper is titled Multi-Faceted Question Complexity Estimation Targeting Topic Domain Specificity. In this research paper, we look into the multi-dimensional. Okay, how do I go to the next slide?
Yeah.
Okay. Yeah, thank you. In the research paper, we look at the multi-dimensional nature of question complexity through a domain-specific lens. Traditional methods assess question difficulty from a pedagogical perspective and only look at it from a surface level rather than looking at its underlying concepts that require the knowledge for that particular question. And if you look at question difficulty estimation, the key factors are standardized testing, which ensures that a test have a mix of all three categories of questions, easy, medium, and challenging. And as a result of that, we can ensure fair evaluation of all students' abilities. And during the evaluation, you can track students' progress, look at areas for improvement, and even change the curriculum according to what we can fix the educational gaps. Okay, let's look over the existing approaches that are there to estimate question difficulty. In QA systems or question answering systems, usually taxonomies are used to categorize and classify questions. These taxonomies can be either flat or treat all questions equally or hierarchical, where questions are grouped into increasingly specific subcategories. On the other hand, domain-specific taxonomies are much better for our use case because these taxonomies are more related to like particular question types, such as opinion-based, and they look at more of the data sources involved in the question behind that. And Bloom's taxonomy is widely used to capture the basic like textual complexity of a question and categorize this based on that. But what we see is that it's very surface level, and for much, like it doesn't look at the other knowledge required for deeper questions. In current research, so there are two studies that we did examine, and in that we feel that they don't look into the text complexity that affects reading outcomes such as student learner comprehension, and like it is not particularly useful for questions that require more specific knowledge. And other studies implement assessment techniques for MCQs, which are more straightforward, which won't be suitable for reading comprehension type of questions. From other research related work that we looked at, one of the papers suggested for generalizing metrics, which does not look at the depth of the knowledge within the specific subject domain. And another study that we saw was generating questions from knowledge graphs. And as a result, it doesn't take into account for topic relevance among the subject itself. And finally, our approach, we believe, takes in care of all of these limitations by looking into question semantics, learner comprehension, and subject-specific difficulty. We introduce a weighted topic importance mechanism that closely aligns with our education system, ensures that our feature extraction is more relevant and impactful. Yeah. So to further elaborate on methodology, we have Yash Nagraj.
Thank you. I'm going ahead with our methodology in order to solve our question difficulty estimation. We introduce 4 metrics that we will be using in order to get the complexity of the question given a corpus of data. The first metric that will be going on with is topic retrieval cost. Topic retrieval cost quantifies the thematic scarcity of specific topic within a document corpus related to a subject domain. It measures the prominence and the convergence of the topic, reflecting its information density related to the overall thematic landscape. So in basic words, what actually it is doing is, given a corpus of data, given a topic, we are calculating how scarce or dense that topic is in the corpus. So in the sense, if the student has to recall it a lot of time in order to answer the question required given the topic. To find the topic retrieval cost, this is the formula that we have been sort of encapsulated. So it goes by 1 minus rank of T given C. So T is the topic and C is the corpus. Corpus is the text document that we use in order to calculate the retrieval cost. Going ahead, the second metric that we use is called topic salience score. Topic salience score is used to estimate question difficulty by analyzing the centrality of the topic with a knowledge graph. So what we do here is we build a knowledge graph given a corpus of data, and then query it in order to get the score. So how actually it is calculated? To calculate the topic salience score, the corresponding article of the topic is identified in the knowledge graph. The inbound links to the article are analyzed as they represent how extensively the topic is referred within the knowledge graph. The score is computed by dividing the number of inbound links to the topic's article by the average number of inbound links per article within a related set. So this is the formula for how the topic salience score is calculated. As you can see in the diagram shown, we have a topic called protocols. Protocols which comes from a text corpus from our syllabus that we refer from computer networks as a subject in engineering. We have 3 or 4 other topics that refer to it. So calculating these inbound links by the average gives us the total topic salience score as to how important that topic is given the subject. The third metric that we'll be taking that we have proposed is called topic coherence score. Here what we do is the metric quantifies the relationship between two topics by assessing how often they appear together in the knowledge graph. So here what we are comparing, instead of comparing one topic, we compare two topics and as to how those topics are related to each other. The score measures the conditional probability of encountering one topic given the presence of another. The coherence is captured by analyzing the link structure within the knowledge graph, which reflects the relationships and semantic connections between topics. The coherence between two topics is specifically defined using the Jaccard coefficient, which measures the overlap between them. This is the formula that we have got for the coherence score. Going next, our last and final metric that we are proposing today is a topic superficiality index. The topic superficiality index is a metric that quantifies the vertical depth of a topic within a hierarchical knowledge structure. It measures how far a given topic is from a primary subject node, which serves as the origin of the sub-knowledge graph. The deeper the topic is in its hierarchy, the higher is the superficiality, indicating that it's more sophisticated or niche. As you can see in this diagram, that the last node that we have goes 4 levels down. So that means that if we have a question given with this topic, then the topic has a specific niche that the student has to quantify. Next, the experimental setup that we use in order to calculate the difficulty. First is a question generation pipeline, which has a text segmentation phase where we have the chapters and sections extract using a Python library. Then we have a question generation engine, which leverages GPT-4 to create 100 questions per section. And these are the question specific niches we use. Next, pre-processing. For pre-processing here, we use a model called Keyword, which is a tool used for extracting keywords from a text. It leverages BERT, a pre-trained transform model, to identify most relevant words or phrases that capture the main ideas of the text. Unlike traditional keyword extraction methods that rely solely on frequency or basic statistical techniques, Keyword uses a contextual understanding of BERT to find keywords that are semantically meaningful and closely related to the content. These are some examples of questions and the extracted keywords given the question template that we have. Next, we'll see some examples of our metrics which we weigh on real world examples, questions that we use. For the topic retrieval cost, we have another pipeline. We first train BERT topic on multiple subject textbooks, then leverage BERT for document embedding, then use clustering methods in order to cluster similar topics together. Then at last what we do is generate topic distribution table. Then at last we get the result where topics and the document. This approach extracts meaningful thematic structures from educational texts using BERT topics robust architecture. BERT embeddings capture semantic relationships, while UMAP and HDB scan, that is our clustering algorithms, ensure accurate topic clustering. This is one example there are 2 examples that we have weighted from the computer networks topic that we had chosen. In the example one, question one explores the niche application of P2P architecture. The lower the mu is here, the retrieval cost signifies the topic's limited coverage within the text. That means it's a very less significant topic in the text. Conversely, question two addresses the fundamental concepts of IEEE 80211 wireless protocols. The higher the mu reflects the topic's greater presence within a textbook. So it is more likely for a student to memorize this than memorize the second question than the first question. Second pipeline for topic salience score. First, we query DBpedia. Here, the knowledge graph we have used is DBpedia, which uses semantic Wikipedia articles as links to get to this thing. So, next is retrieve a set of Wikipedia articles that contain incoming links to the article associated with the keyword. That fetch the count of incoming links for each article within the given article set. Calculate topic salience using the formula from methodology section, whatever the section. Then we aggregate metrics for topic salience. These are some examples for our topic salience questions and score that we have got. The third pipeline in order to calculate topic coherence score is goes like this: extract keywords from the question, query DBpedia to retrieve the set of incoming links for corresponding Wikipedia articles. For each keyword pair, we calculate Jacquard similarity between keyword 1, keyword 2, aggregate pairwise coherences, and then find at last get the coherence score. These are some examples and the remark on those. You can see that the first question refers to TCP and UDP for client-server applications, exhibiting higher coherence. Because TCP and UDP are both protocols used in network topologies, you can, as you can see, it gets a higher coherence score. As we are using a Jacquard index, we get a higher coherence score. That means TCP and UDP are closely related to each other. The second question you can see that we have contrasting ARP with WAN routing. This presents a lower mean coherence. This suggests a weaker association as ARP is typically discussed in the context of LANs rather than WANs, potentially leading to more challenging cognitive process for integrating these concepts. So the last and final pipeline for our last metric, topic superficiality. First one, identify keywords, extract relevant keywords from the question. Locate corresponding articles for each keyword. Again, query the DBpedia knowledge graph. Next, measure the graph distance. Determine the graph distance from computer network article A and to each keyword in article A1. These keywords are from the question that we have extracted. Then compute superficiality score. Use the measured graph distance as superficial scores for each keyword. You can see some examples here that the SMTP is at a level 2 in the DBpedia. So it gets a score of 2. So it's a level, second level in the knowledge graph. The next one you can see is we use WEP. WEP is 1 above SMTP. So you get the superficiality score of 1.2. Then these are our, how do I say, aggregation evaluation metrics that we have used here. This is our pipeline that we have used framework for generating our question difficulty. Now I want Mr. Sujay to, in order to tell us about the evaluation that we have.
Now, when we are trying to evaluate our metrics, whether they're good or not, we tried a few different ways, but then we ended up on this method because it seems pretty scalable. First, we ranked all the questions using our metrics, and with those metrics, we fine-tuned the GPT-4 model by prompting it, giving labeled examples from human evaluated experts. From that, we can see we can get an estimation of how difficult one question is from the other. On top of that, we use the ELO system where we compare two questions and we ask GPT to rate which is more difficult with the few short prompting of human experts, so that we get actual ranking of all the questions, and we compare those rankings with a score of our model where we stack all our metrics using linear regression as an ensemble. And we used a 5-fold cross validation to make sure that it doesn't overfit. So after we trained it on our small data set, this is the ELO distribution. There are few gaps in the data set, but as you can see, it is pretty widespread. Yeah. So our After training our model, we have a mean squared error of 3.6 and an R squared score of 0.42. This obviously shows that there is room for improvement. And then before we go to the conclusion, we would like to tell some problems. So this is the pipeline that we're using for our question generation. Once we get the keywords extracted, it is a straightforward pipeline where we query the graph engine. Now the graph engine is PBpedia. PBpedia is based on Wikipedia. Wikipedia might not represent the correct link structure that we need for college education. It might not be structured in that way. It might include cultural references or non-literary references as well. So to improve this model, the easiest way is to develop a custom knowledge graph for our specific use case. And when we are using topic retrieval cost, we have used multiple textbooks from computer networks in our syllabus. If the more textbooks we have, the more context we have, seeing that which topic is more prevalent and which is less prevalent. I would like to conclude today's talk by saying that we came up with 4 metrics to discuss topic domain specificity in question difficulty estimation. The 4 topics that we came up with was topic retrieval cost, topic salience, topic coherence, and topic superficiality index. To summarize, topic retrieval cost looks in a more intuitive way. It looks at whether the textbook has this topic as a more prevalent or less prevalent one. Topic salience looks at how common this topic is talked about in that domain when we're using the knowledge graph. And then topic coherence, it sees if the question has multiple topics, it sees how often those 2 topics occur together in the context of the syllabus, so that if they're nearer together, we consider that as easier to remember. And the superficiality index considers what level of understanding that the student needs to have to answer the question, because if it is far away in some corner of the textbook, it is harder to answer. And then this is more of a subjective evaluation. By using these metric scores, we have brought about a quantitative approach to it. Also,